Well, in problem number 6, we're given a piecewise defined function, and 3 statements are listed, and we have to determine which, if any, of these statements are true. So let's start with statement number 1. Let's see if the limit exists. The limit, as x approaches 2 from the left and from the right, will be found by using this first piece. This is where the function is defined when x is not equal to 2. In other words, when x is approaching 2 from the left and from the right. Direct substitution will fail if we try putting 2 in for x, so let's factor. We get x plus 2, x minus 2 in the numerator, x minus 2 in the denominator. And the factors of x minus 2 eliminate each other. So we're left with the limit as x approaches 2 of x plus 2. Well, now direct substitution will work. We'll get 2 plus 2, which is 4. So statement 1 is true. The limit does exist, and the limit is 4. Now the next problem, or the next statement, number 2, says f is continuous at x equals 2. Well, for our function to be continuous, now 3 conditions have to be met. Number 1, the limit has to exist as x approaches 2. We've proven this. The second condition, the function must be defined when x equals 2. And that is true, because when x equals 2, f of 2 is 1. And because f is defined, our second condition for continuity is met. And the third condition is now that f of 2 must equal the limit of f as x approaches 2. In other words, does this function value equal this limit value? And the answer is no. So the second statement is false. This function is not continuous at x equals 2. Just to review, we've thrown these 3 conditions for continuity at a point on the screen. We saw that the limit existed. This was true. We saw that the second condition, f of c, was defined, but the problem was right here with the third condition. That's why our function is not continuous at x equals 2. Now the third statement that we need to look at is f differentiable at x equals 2. Well, remember, for a function to be differentiable, it must be continuous and smooth. So we can tell that statement 3 is false because this function is not even continuous at x equals 2. So now, of the 3 statements, the only one that is true is option number 1, which is answer A. Hopefully you found this video helpful. Thank you for watching.